Hello guys, we can just continue with this Python numpy course. Okay, in last course I already introduced the basic operation like how to create a empty array and how to do some the math operation to the array. Like you can just compare two array, also do some math between array and the other array, also between the array and the scalar. Like you use the array multiply 2, that means actually will be double time of all your element, no matter how many dimension it is. Today you maybe you already have some feeling like the array has a similar function as a list. We can say yes and no. I will show you why we say yes and why we say no today. And first of all, let's just import numpy and just create a range, just like the Python regular range layer. So here's array actually, right? So you can see we can use index just like the Python list. We can use the list number also begin from 0. So 0, 1, 2, 3, 4, 5. So array 5, the value is 5, right? So we can also do some slicing. This is the same function, like similar like a list, right? Again, you can see this lower, this is higher, so it should be greater or equal to lower, but should be smaller than higher. So actually it's 5 to 7. It's not from 5 to 8. Okay, and also you can here's a very important thing here. And actually, here's a little difference between Python list and this array. You can see this slicing is not a copy but a view, right? So the view, the meaning just means it didn't just generate the other new array, but instead it just give a view of between 5 to 8. So if you change the value, the original, you also change it to 12, right? So, but in the Python list, I can give you more example. For example, this is the Python list, right? One, or you can do the same thing. Let me copy it. So here, we just define a new list, which is A. Then if I say A1 5.a to 8, we do a similar function. Can only be assigned to iterable, right? Yeah, because I think you need to put 12.12.12. Yeah. So, but you can see here A also do change. Okay, I think maybe in this Python 3 there's something change here. Because I remember in Python 2, if you do this function, the original A will not be updated. The reason is when you take the slice of the original list is do a copy in the memory. So you only, whatever you do, only impact the new created list. For the older one, you will not be touched, right? But with the numpy array, you always be touched, no matter the list is big or small. The reason is just to save resources, because here, just for the purpose to the teaching, but in the real production, maybe the array may be 1 million or 2 million or sometimes a billion, right? So if you always do a copy, you can see you will run out of the memory very soon. Also, it's not efficient. So that's why in the this numpy always use a view, not a copy, right? If you want to do a real copy, then you need to call like the copy the function. I believe we have the copy. Let's try. Yeah, you can see this is a copy function, right? Here, just create a new one. B equal to array.copy. So you can see the B is a new one. So anything you touch the B, you will not impact to A. So this is the like a Python list. Okay, and now we just here's more example to show you what's the difference between the view and the list here. You can see here we give this one. Actually, I should do this one. Let me test again with the normal list. Okay, so we know that the A is this one, so we just define B equal to A 5A. So B is a slicing of A. Then we say B equal to 12.12. Oh no, I just say 20.20.20. Okay. So let's check A. You can see A didn't do any change here, right? So that means B and A is totally different. B is just a copy of A. There's no relationship. But in the meantime, if we do the let's do the numpy, we do the same thing. BRR equal to ARR 5 column A. Do the same thing. So BRR equal to this one, right? So we do the same thing. BRR equal to, like we just give here a new one. Okay, we just change here to a new. Let's see. Let's do this one. 0 equal to 20. Right. So we input the BRR. You can see it do change, right? But in the meantime, I will go to A. It also change, right? So that means again, normally Python 2 and Python 3 list always do a copy. So when you do a slicing, you do a copy. But when you with numpy, when you do a slicing, you always do a view. You will not do a copy unless you explicit to do copy there. Okay, and also that's a similar way, just in between list and the array. You can see you can also use this method. This means copy everything, right? So when you go to this one, yeah, because array slice only between 5 to 8, so only 5 to 8 change to 64. So here again, prove to you why in this numpy we always use view, right? So if you really want to do a copy, like I said, you need to use this way: array.copy, then parentheses. So here we'll explicit to tell Python to copy, not to view. And now, like I say, in numpy we can support not only one dimension; you can support as many dimensions you want, right? So I can just give you some example how we just define the multiple dimension. Like we can say array 2D .n dim, right? So here you can say 2 dimension. Row is 3 row, also 3 color layer, right? So just like a list, just like a list within list, you can also do the same way. But here is array, it's not list, right? So you can see 0, 1, 2, so it's 7, 8, 9. So this is okay. So if we want go to get a special element, if we only want to get a 9 or go to get 7, you got 2 method. Once use 2 this square bracket, the other is just to use this one called this one just within the same square bracket, then use a comma to separate. These 2 method is the same, can get the same element, but the sequence is important. The first one always be row, the first dimension, the second one will be column, right? You can use 2 ways to get out of the special element here. Okay, and then we can just continue to define a 3 dimension, which is called 3D, right? So here's the 3 dimension. You can see that's 3 square bracket, right? So you can imagine it, right? It's not 2D anymore, it's 3D. So here we can check how can I know it's 3D. one is we can use the property undien, right? So the other is we can just check the shape. Remember, shape is very important. So the 2, 2, 3, right? 2 just means here's 2, right? 1, 2. Then in each group we have 2 row, then 3 column there. So 2, 2, 3. So for this one, we can also do some copy. Like we can use this value called all value, right? So we can take a look. You can copy whatever dimension you want, right? So here we just copy 2 dimension because we define the index 0. So we only copy here. Then we after do a copy, we change this one to 42, right? So here you can see we already changed it to the first part to the 42 already, right? But in the meantime, we can do assign back. So you change your back. Here I just want to let you know that the 2 method to put a value to the element of the numpy. One is use scalar. This we call it scalar. Scalar just means one number. One number means scalar, right? The other just go to the same size. Same size. This one should be same size. Because you remember this dimension. The second dimension should be 2 and 3, right? So this all the value should be 2 rows and 3 columns, right? If not same size, you do this equal, then you will give it some error. Now we also talk about how to do the Boolean indexing, right? So far we always use the number as the indexing, but actually the Boolean can also do some indexing here. For example, I use this one. I create a new numpy. The numpy has 2 people, the name is Bob, right? In the meantime, I can create a random number. This is a random number between the is 7 row, 4 column. We can give it to take a look, right? This random just similar like a Python random. So it's 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7. So it's 7 rows, 4 column. So sorry, let me so here we just do a names. So here just like a Boolean, just to do some condition. You remember the names is equal to this Bob and something else, right? So when you equal to condition Bob, then you just they will compare element 1 by 1 in this same array. So it's a true, false, something. And then we can apply the same condition to the data array. So you can see now why we only have 2, because the first one is true and the fourth one is true, right? Just like in the same position as Bob, we see the same array there. So I hope you can understand this part. And let me explain again, okay? Name is equal to this array. So here we do a condition. This condition we will do some filter. Then finally, you just give a new array. The array, the number if the position is equal to Bob, it gives you true. If not, it gives you false, right? So I apply this one as a filter in this data. Data originally has 7 rows, but because only 2 position is true, so finally data only output a 2 as the new data layer. Okay, I think that's it for this part, and we will continue later on. Thank you.